Pure Handbook 1, Lesson 5, Area and Length. In the first part of this video, we're going to look at finding the distance between 2 points. So in this sketch below, I've got my 2 points, the first one x1, y1, and the second one x2, y2, and I want to find the length between them. So what I'm going to do is consider what distance I travel horizontally, and then what distance I have to travel vertically. And hopefully we can see this forms a right angle triangle. So to find this horizontal distance, it's just the difference between x1 and x2. So this would just be x2 minus x1. For the vertical distance, it would just be the difference between the two y coordinates. So it would be y2 minus y1. Then we can just use Pythagoras' theorem to find out what this distance is going to be. So I square the two shortest sides. So I square x2 minus x1 and y2 minus y1, add them together, and then square root to find what d is. So here is the formula we would use. Try and get into the habit of using this formula. It might sometimes be tempting just to do a sketch and just to consider the differences, but when you get onto some more of the algebraic examples, it's going to be useful using this formula. Looking at example 1, we've got our 2 points A and B, and I'm going to find the length of the line segment. So I just do what I mentioned there before, find the difference between the two x coordinates. So the difference between minus 2 and the 4, so I need to do 4 minus minus 2. And then difference between two y coordinates, so difference between 5 and 1, 5 minus 1 there. Now what I'm going to do is work out what's in the bracket. So I've got a 6 in my first bracket and a 4 in the second one. Add 6 squared and 4 squared together to give me the square root of 50. Now I'm not going to change this to a decimal, but I'm going to do a little bit more with this. I'm going to simplify this third. So square root of 50 can be broken up into square root of 25 and square root of 2. Square root of 25 being 5. I can't do anything more about the 2. So the answer there would just be 5 root 2. The next example is a little bit different because I actually get told the length here, but I don't know what the second y coordinate is. So I'm going to go ahead and plug everything I know into the formula. So I can work out the difference between the two x coordinates. So it's just minus 1 minus the 2, x2 minus x1, and then I square that. And then I do y2 minus y1. So I do a minus minus 3, and then square that. So I'm just doing it in terms of a, because I don't know what that second y coordinate is, so just leave it as a. So normally what I do is I square root that, and I get the distance, but I don't know what that second y coordinate is. But what I do know is this is going to equal the square root of 13. The next thing I can do then, because what I want to try and do is find what a is, so I need to isolate that, is I can square both sides to get rid of these square roots. Okay, the whole of that left hand side is being square rooted, so I can just square the whole of that side. So what this leaves us with is in the first bracket I have minus 3, and then I'm going to square that, and then I've got a plus 3, because the two negatives next to each other are going to make a plus, and then I've just got 13 on the right. Okay, I've got rid of that square root. So minus 3 squared is going to give you 9, so I'm going to take away 9 from both sides. It might be tempting to expand this a plus 3 all squared, but what I'm going to show you hopefully is actually a bit of a quicker way. And because I want to get a on its own, I want to get rid of this squared part. So I'm going to square both sides, just leaves me with a plus 3 on the left. On the right hand side, now it might be tempting just to leave it as 2, but when you square root a number, you get a positive and a negative solution. It's really important this, otherwise we're going to miss a solution. So now what I'm going to do is I'm going to take away 3 from both sides. So I take away 3 from the positive 2, which is going to give me negative 1. But I also have a second solution, and that's when I take away 3 from the minus 2, I get a equals minus 5. You might be thinking why there are two solutions. I'll do a little quick sketch to show you how. Say I've got my point C here. There's two possible places where D could be where there is a distance of root 13. Okay, they both have the same x value of minus 1, but it could be up here with the minus 1 as the y value, or it could be down here with minus 5 as the y value. For this third example, I'm going to just leave the solution there for part A because it's more of the same thing, but this question just kind of leads you towards making sure it's in that form k root 5, basically saying leave it as a certain. It's kind of giving you that hint of you're expecting the square root of 5 there at the end. So the fact that we get 7 root 5, didn't mean to cross that out, we get 7 root 5 there as the answer. We know we can be confident that we're correct there. What I'm going to do with this question though is I'm going to focus on this part B, verifying that the angle PRQ is 90 degrees. So what might help is doing a little sketch here. So I've got my 3 points here, R, P and Q. I'm going to verify that PRQ, so it would be this angle here, is 90 degrees, i.e. a right angle. Now, if you've got a right angle triangle, the three sides must obey Pythagoras' theorem. So what I'm going to do is I'm going to work out the length of all three of these sides and show that it does definitely obey Pythagoras' theorem. In that I can square the two shorter sides and I get the longer side squared. So what I'm going to do is, firstly, the length of QR. Now from part A, I know that this is the square root of 245. I'm going to use square root of 245 rather than its simplified surd version, and hopefully you'll see why I do that in a second. I need to find the length of RP. So R has coordinates 8 minus 3, P has coordinates 12, 5. So use your formula. So do 12 minus 8, difference between two y coordinates, 5 minus 3, the difference between the two x coordinates, and I'm going to skip a few steps this time because I think we've hopefully had a bit of practice by now at this. We just get the square root of 80, so I'm going to put that on here. And then I'm also going to find the length of QP. So, yet again, use your formula, and I will skip a couple of steps here just for time's sake so I don't overrun too much on this video. I get square root of 325. So now what I'm going to show is that if I do the square root of 80 squared, so the length of RP squared, plus the length of QR squared, then this gives me the length of QP squared. So then I just write some conclusion like obeys Pythagoras' theorem so PRQ is 90 degrees. It is a right angle. There is an alternative approach that you could take, and that's that you could find the gradients of QR and RP, and you could show that they're perpendicular to one another. So you can find the gradient of both line segments and then multiply them together to get -1. So that is an alternative way to do it, but I wanted to show you this way because it's using the new material of finding the length. The next problem we're going to look at is one where we're going to find the area. Now, with these types of questions, as we saw in the last one as well, drawing a sketch is really useful. It doesn't have to be a work of art, as you can see with my attempt here, but it just has to be something where you can just see what's happening with the question. Now, you might be thinking, find the area. All you've got is 3 points. You might have to do some trig first, or things like cosine rule to find angles and things like that, or use half AB sine C. No, we don't need to do any of that, because if we just do our sketch, what we should hopefully see is that BC is flat here. okay? Because just the x coordinates 4 of the B and x coordinate of C is 7, and they both have y coordinates of -6, so it is completely flat there. So I know that BC just has a distance of 3. Then if I'm working out the area of a triangle, it's just base times perpendicular height times a half. And in terms of the perpendicular height of this, well, it's just the distance from the base of this triangle up to A. So it's just this here, so I'm just going to draw this in here. I hope you can see that if y, for the base, B and C have a y coordinate of -6, if the y coordinate of A is 8, then that's going to be a difference of 14, okay? 8 minus -6 is 14. So the area of the triangle is just a half times the base of 3 times the height of 14, which gives us 21. We can just leave it as 21. We don't need to put 21 centimeters squared, 21 meters squared, feet squared, whatever. We don't know the units, so we just leave it as 21. If we're given units, of course we should put that in here, but we don't know here, so we just leave it as 21. Finally then, we're going to look at an exam question, but this is quite a lengthy one, so I've split this up into various parts here, because it's 15 marks altogether. And it's kind of just a nice kind of combination of things that you'll be doing in this lesson and the previous lessons as well. So let's get into it. We've got the line L1 passes through the points P and Q, and we're going to find the equation for L1 in the form y equals mx plus c, where m and c are constants. So this is taking us back to earlier lessons we've done. We've got 2 points here, but we don't know the gradient just yet, so we're going to need to find that so we can then form our equation of the line. So I'm going to start by finding the gradient. So remember, your formula for the gradient is y2 minus y1 on top, so 8 minus 2. And I do x2 minus x1 on the denominator, so 11 minus minus 1. So this is just 6 over 12, which just simplifies down to a half. So now I've got my gradient, and I've got at least 1 point in the line, so now I can find my equation. So I'm just going to use the first point here of minus 1, 2. And then I'm just going to simply put it into my equation of the line formula. So I'm just going to use this. Remember, if you prefer using y equals mx plus c, you can do that. So just sub in everything I know. And then what I'm going to do is just multiply both sides by 2. Actually, in fact, I'm just going to multiply out this bracket here because I need to leave it in the form y equals mx plus c. So actually I won't multiply by 2. I'll just multiply this bracket out here, and then I'm just going to add the 2 to both sides. And that is our equation of the line. So then we have this next question, a little bit trickier here. There's quite a lot to consider going on here. So this is where we really do recommend that you draw a sketch. We're told earlier on that the line L1 passes through points PQ. So let's draw that now. So this is going to be my line L1. And here are my points PQ. And I know that the line L2 is perpendicular to this line. So here you've got at right angles this line L2, and you know it passes through this point R, so let's sketch that on here, and they intersect here at S. Okay, so what we're trying to do is we're trying to find out what S is. So basically what we're looking at is where do lines L1 and L2 cross. So to find that out, I can solve this simultaneously. But before I can solve it simultaneously, I need to know the equations of both lines. Now I know the equation of the line L1 from part A, but what I don't know yet is the equation of line 2. So what I'm going to need to do is find the equation of L2. Now because I know that L2 is perpendicular to L1, the gradient of L1, so we found that out in part A, was a half. Okay, so just scroll back up here. We found that out in part A. So the gradient of L2, because it's perpendicular, it's going to be negative 2. It's going to be the negative reciprocal. So do the inverse of that fraction and then change the sign. So then we have our gradient of minus 2. We have a point on the line, which is 10, 0. So we're just going to plug it into our formula. So y minus y1, but that's just y minus 0 here, minus 2 times x minus the 10. And then this just gives me y equals minus 2x plus 20, and that's the equation of the line. So next thing is to find out where they meet. So I've got y equals half x plus 5 over 2. That's the equation of L1. And I've got the equation that I just found there, minus 2x plus the 20. So we're going to solve these simultaneously, and later we will look at simultaneous equations in a bit more detail, but linear simultaneous equations hopefully is something you can do from before. You can do this on your calculators, but I'm just going to quickly show you how you could do it, just by simply setting them equal to one another. Okay, so they're both y equals, so we could just do this. In a future video I'll show you how you can do this on your calculator, just to check or to make the process a little bit quicker. And then what I'm going to do is going to add 2x to both sides, take 5 halves from both sides, leaves me with 5 halves x equals 35 over 2. This just gives me x equals 7. Sub x equals 7 back into either equation. I'm just going to pick the second one. So I'm going to sub into equation 2. So to find the y coordinate, so hopefully this shouldn't be anything new to you. It's just solving a pair of linear simultaneous equations. And finally I get this point of 7, 6. Part C is just 2 marks. It's pretty much what we'll be doing throughout this whole video. Find the length between 2 points. So this wants us to find this length between R and S. So just between 10, 0 and 7, 6. Remember that 7, 6, we just found that in part B. So I just use the formula. Because to show that question, make sure that you do show the necessary steps. Sorry, not an 8 there. It should be 10. So I'm going to do x2 minus x1. So just really hammering on home the key concept, what we look in this lesson. Find the distance between 2 points. So I'll do 3 squared plus the 6 squared. And just maybe showing that extra step than I normally might, just because it is a show that question. So I'm going to show how I break down this third. So I'll get the root 45, split it up into root 9 and root 5, and that's just 3 root 5. Then we're on to the final part, which says hence or otherwise find the exact area of the triangle PQR. You're going to see this word hence or and also otherwise throughout a lot of exam questions. What it means is use something you've done previously to help you with this. Using a sketch here is definitely going to be helpful. And the reason why is because you've just worked out what RS is, so you know this has a length of 3 root 5. Okay, so length of RS or SR has a length of 3 root 5. So if you want to find the area of this triangle, what we can do is work out the length of PQ, and then we have the perpendicular height of the triangle, which is SR, which we've already worked out. We can find the area of the triangle. So I'm going to find the length of PQ. And yet again, we've been doing this all throughout the video, so you should be experts at this by now. But just in case we need to do it one more time, we do 8 minus the 2. Hopefully in your booklets you've got the coordinates here that I'm using, so these numbers make sense. And then I'm just going to leave it as 180, square root of 180. I could split that up if I wanted to, but because I'm just trying to find the area, I'm not leaving it, just find the length and just leaving it as that. I'm just going to leave it as square root of 180. So to find the area, I do half times the base. The length of the base is square root of 180 times the perpendicular height, which is 3 times square root of 5, and that gives me 45.